Afternoon. This is me, Akshar Patel. I work as a product manager for Cisco Secure Connect team. Today, I'm going to present to you how you can secure your branch by connecting and securing through Secure Connect. So let's dive into the content. My agenda is very simple. I'm just going to introduce first to level set what Secure Connect is, and then we will go over into how branch connectivity works in our Secure Connect platform. From there, we will dive into our cloud security functionalities. Specifically, I'm going to emphasize on firewall today because that's been our key evolution that we are driving through this platform initiative. And then we'll wrap it up with a nice demo of this new stuff that I'm going to announce here at TechField Day today. So let's look into some introductory content of what Secure Connect is. Before we dive into Secure Connect, I want to take a step back and understand how SASE comes into the play here. So the brief understanding about SASE architecture is that how can I bring how can I join the force of network and security together to make it a platform approach here. And you first connect something and then only you can secure, right? So connectivity works with security hands in hand. But what SASE does is bringing the best of SD-WAN capabilities and best of security capabilities in the cloud together and help you achieve the outcome that you're looking for. So there are multiple motions across the SASE around the market. But when it first introduced, the customers who already have their deployments or at least to some extent have the components available in their infrastructure, but they were so disjointed that the actual architecture of SASE was next to impossible, I would say. Not next to impossible, but I would say like the integrations were really challenging in that case. So they moved to the next evolution stage where the subject matter expert vendors of each components, which is network and security, would come together and bridge the gaps in their systems. By bridging the gap in their system, they came closer. But still, it was multi-vendor solution. Like you might buy an SSE full capability vendor solution and the SD-WAN full capability vendor solution and try to connect together the dots via their integration system. From there, the evolution continues into the single vendor integrated SASE. What that means is like someone like us, Cisco, we have SD-WAN solutions, we also have SSE solutions. So those customers who would prefer to move in this direction would just come with one vendor, provide me everything, and I'll connect the dots here. The peak here is the single vendor unified SASE solution, which is basically how can I just buy one platform from one vendor and do everything on that? And this is where Secure Connect plays the role. So that's what I'm going to present today, Cisco Secure Connect, our unified single vendor SASE solution from Cisco. What is it built on? So there are two robust platforms underneath. One is Meraki SD-WAN and the other one is Umbrella SSE solution. They have been out there for a while. They have been proven with all the scales and all the capabilities that they bring to the table. What Secure Connect was able to achieve is bringing these two platforms together and build a unified solution on top. So that's what we are doing here. This is our architecture. So you have connectivity points, which are either your branches or your remote access users, or in some cases, you're trying to implement one or the other methods of ZTNA, right? And in this case, those are all my connectivity options. But then how can I bring those connectivity options together to access the resources, whether they are on internet, how can I access them securely? If they are on premises, how can I access them within my network parameters? If they are in your public-private cloud or SaaS-based deployments, how can I access them securely? Those are the challenges that the platform is trying to solve here with bringing this architecture together. So as you can see here, those branches or remote access users, they all connect to the platform through our traffic acquisition headends, which we call it like cloud native. From there, it runs through the various security engine and checks against all your security requirements as needed, and then it reaches to their end destination, depending on where they are traveling to, whether it's east-west or north-south. So as I mentioned earlier, I'm going to focus on branch connectivity. So just a shift on this architectural slide, how the branch connectivity looks like. You have an SD-WAN branches. Now, there are multiple ways you can connect your SD-WAN branches to the SSE platform. A traditional method when you use a multi-vendor approach is you have to try to build the IPsec tunnel, for example, to the cloud head-end solutions that the SSE vendor provides. Since in our case, it's a single vendor unified SASE platform, the idea is Meraki SD-WAN branches will connect through the Meraki's USP technology, which is called Auto VPN, to our fabric, and then the fabric will take over from there in order to route the traffic to its destinations. I'm going to deep dive into the Secure Connect architecture, where how the head end actually acquires the traffic, and then what are the connectivity points they have between the two. So as you see here, the branches will have various means. We can also support IPsec if needed, but Auto VPN is our primary method to connect Meraki SD-WAN branches. And then we use the routing protocols like IBGP for peering between our fabric and the SD-WAN branches, whether it's multi-region or single region. So as you can see, from that connectivity standpoint, then we have various components in our data centers that runs the cloud security service, the SASE fabric interconnectivity services, and you as a customer or organization, if you need to support hybrid environment where your remote access users also needs the same connectivity, whether they work from office or work from anywhere else in the world, then you have a capability of deploying the remote access connectors in the same data centers. That way, now your full stack is within the same data center. You don't worry about latencies. For instance, like in many cases, what happens is when your traffic is getting to the head end, from that point, it's being sent somewhere else to get the security checks done. But in our case, because it's same DC, same stack, it doesn't really go somewhere else to get checked and come back here. Stays within the same bucket list, and then we send it out to wherever the destination is. So in a way, we are improving our latency measurements here. Now, the beauty of SSE Fabric Interconnect is it has optimization techniques in place as well. So in this example, if I have deployments in Europe 1 region and Europe 2 region, the interconnect fabric will take care of your connectivity from one region to another region. So you as an organization don't need to worry about how am I going to distribute the routes or what are the techniques I'm going to use to optimize my traffic. It's all on us. So this whole solution is provided as a service to the customer. So this is a demo. Now, before I jump into the demo, what I want to highlight is how simple it is to kind of onboard the branch into the fabric. Because if I have to do IPsec, for example, then you will end up configuring the IPsec parameters on one end, matching them on the same end, try to make sure that the assays, like these phase 1 and phase 2s match. You have to go through all this process in order to do that. Likely you're going to end up taking at least 5-10 minutes to configure an IPsec tunnel properly and get this up and running. In my case, what I can show you is our scale is up to, I would say, like 200 plus sites within the less than 5 minutes we can onboard. But in this demo, I'm going to show you 3 sites connecting to 3 different regions and establish this routing connectivity, fabric connectivity, SD-WAN, all those things within a matter of minutes. So let's jump into it. Secure Connect shows up into Meraki dashboard, as you see here. When you go to Secure Connect, if you're interested in how things are going on, you go to the overview page where you will see all of your nice data like security, events, sites, connectivity, remote access, users, etc. In this case, I'm going to connect sites. Since I'm onboarding first time SD-WAN branches, I go to connect Meraki site. All of your SD-WAN branches shows up by default, so you don't have to go find something. I'm going to search for New York, connect to the New York branch, and then assign it to the region. So since it's a New York branch, I'm going to select the New York data center, which is the northeast region in the US territory. Then I'm going to find another site which belongs to Frankfurt. So it's a Europe region now. I'm changing it globally as we speak. So this is a Frankfurt site, connecting again same way, selecting the region. Keep in mind that when I'm selecting the region, I'm not actually doing any deployments, or you as a customer is not doing deployments like spinning up a virtual machine into the data center, nothing. It's all on us. So that's another key value prop here. This is a Denver site, which will connect to the US Central. So as you see, I have two US region, one Europe region. And once I'm done, I just hit finish and save. After finish and save, this whole process is basically establishing the auto VPN connectivity, enabling routing, and then sharing route tables across sites and the interconnect fabric. And once it is done, you'll see that my sites are up and running. You can verify actually which subnet are actually routing over the fabric as well from the same dashboard.
Just a quick question on that. You have US, Central, West, Europe, 1, 2, 3, 4. Are they all located in the same data center, or that's also
they're all different
geo-distributed? Because it's kind of hard to know which is West Europe, what is East Europe.
Yeah, so when we clicked on that region, you will see that the cities where the data centers are located actually. So when I clicked on Europe one, it was London and Frankfurt. Now the way data center works is you have a region which has two data centers. One is primary, the other one is secondary, right? So in the event when I'm connected to the primary and for any reason something happens, my connectivity seamlessly transition to the secondary data center. That's why each region has two data centers as a pair to each other.
You have global coverage, also Asia, Africa, and so on?
We do. So I have a slide that will actually show you the map and where we exist in the world map here from the coverage perspective. So bear me just a few minutes there. Brownfield. Now, traditionally, if brownfield customer who might have a hub and spoke topology or a flash mesh topology, or maybe they are not connected, whatever the case may be, right? The seamless connection or seamless onboarding is a key here. And what we were able to achieve is, depending on how your connectivity or the fabric is, whether it's hub and spoke in this example. So you have either your cloud provider as a hub, or you have a data center as a hub and then multiple sites as a spoke, no problem. You can actually onboard existing setup as it is to Secure Connect. And then we will actually help you achieve all the route priorities or connectivity tissue between the two, depending on your choices. So if I show you one example, let's say I have a hub, which is a data center located in on-premises somewhere. And now you're trying to onboard this whole architecture to Secure Connect. That's fine. You onboard that, then it's your choice. Do you still want to route your traffic directly from a branch to the hub, or do you want to route them from our fabric? If you decide to route those traffic directly to your hub, no problem. You just change the hub priority in our VPN fabric, and it's as simple as that. So for brownfield customers, depending on your topologies, we can help you achieve the use cases here.
So in a Catalyst SD-WAN, its default mode is really full mesh. And so that means that the branches networks are exchanged directly with all of the other branches, and longest prefix match will always win. And so if you only advertise a default route when you connect to this environment, you're really only securing your internet destined traffic, and you're not necessarily securing your branch to branch traffic.
So to correct there, when we advertise default route, we actually send everything to our fabric. But then when I onboarded the site, you saw that there was a subnets that I was showing, which are part of the fabric, right? That becomes my route table. So default route is there at the end of the route table, just to make sure that when you're trying to go to the internet destinations, I still send you through secure channel.
I'm sorry, in that first picture you show with BGP connecting, so I communicate that dynamic route learning happens from that connection, from that BGP session that's going on. Okay.
Right, yeah.
I think I get it.
Yeah. So default route always stays at the bottom, because we want to make sure that you are sending it through fabric securely out the internet. But before default route, it's all specific routes learned by that fabric onboarding process. Hence, all of your traffic can go through our fabric to either other branches or to the hub, depending on your choice. Yes.
Just to make an example out of this. So let's first start with the extreme, yeah? You have two offices, both located in the same city, same ISP. Mm-hmm. They both would send their traffic up to the Secure Connect cloud, mm-hmm. and then back. So kind of the benefit is you can do all your nice inspections in the cloud, but of course a direct connection, let's say in the way before SD-WAN was connected, would have been in this concept maybe have a bit of latency advantage, yeah?
So that's why you get these flexibilities, right? Like you can pick and choose your connectivity priorities.
But once you go for Secure Connect, everything is sent to the cloud and then back to any office location.
Right, yes. Even within, yeah.
How do you, oh, sorry. Okay, so then how do you compensate the additional delay? Because that's the reason, because some companies then would rather pick a direct connection towards the cloud using a private circuit than using the internet. So in which way is this compensated then if you're getting to the cloud location, which you would be performing all the inspection and then back?
So when you say private connectivity, do you mean by like you have a lease line or something?
Usually it's some specific MPLS circuit, or you have some agreement with a transit provider, call it Equinix or any other similar. Right. But you don't go straight through the internet. You have another, well, faster way of getting there. Because there should be a way in which you can have high throughput and at the same time compensate then the round trip time between both locations and, I don't know, the internet. So how do you actually compensate this? Because I understand it's wonderful to have things in the cloud, but if I have to send something up and then down again, then what happens with the traffic that is especially sensitive to delay, for instance? The internet is a wild place.
Yeah, I understand that.
I have a follow-up question on that one. Is there an average limit, a kind of a bandwidth that you trace on? There should be no latency, a kind of a percentage of the kind of stuff?
One more time.
I mean, is there an average bandwidth you need to stay the connection up?
Yeah, so the first and foremost, the tunnels will provide you like 500 Mbps bandwidth per uplink per site. So if you have, let's say, 2 uplinks, then it's 1 gig aggregated, right? So that's one thing that we can guarantee here. The second one is the latency between the site and the data center is dependent on your internet connectivity, but within the data center or between the regions, it's all something that we, as I showed you in the fabric, will be optimizing the routing and the fabric connectivities based on the interconnect mechanism, right? So in that case, we improvise there. But if the dependency is on the internet connectivity, that's something that we don't know how to control because it's an ISP problem at that point. Coming back to the question about like within the same region, a branch is talking to another branch. Previously, when you have an SD-WAN, like traditional SD-WAN connectivity, unless you are running mesh topology, even that won't be possible because what you're going to send your traffic to the hub and hub will route it to another branch, unless you're running the mesh topology. So in this case, what you're doing is simply replacing that hub with our cloud data centers. Right, so that's the advantage here. And then all your security services that are running in the cloud will actually help you improve your performance because in your data center, if you have a hardware which is running security, you will likely impact your bandwidth, if I'm not mistaken.
At the same time, you're also introducing a hairpin that didn't used to be there. So you're increasing latency, especially in region, of course.
So again, I'm replacing that hub with the cloud hub. I'm not actually adding this cloud hub in addition to the hub, right?
That's assuming you're not running full mesh.
Full mesh, yes. So if you're running full mesh topology, right now that will be a limitation that you will have to deal with in these configurations. Yes.
Then how many active tunnels would you have from a branch?
So that also depends on how many uplinks you have. For example, one uplink with 2 data centers will have 2 tunnels active at any given time, but only primary data center will be sending traffic or receiving traffic. The second one is going to be standby. So the moment the primary is infected, you move on to the secondary data center.
I would like to follow up on this actually.
Go ahead.
Then assuming you have an uplink and everything is working and wonderful and well, the delay is not a problem at this point, then what's the maximum capacity that you will be handling for this security policy while they're being applied, and what's the bandwidth you can handle? I'm sorry if this was explained earlier because I didn't catch it. Because
no problem.
Assume I can do it in the same very box locally and it's going to handle, let's make a number, 1 gig per second. Then what's the advantage of sending it to the cloud? I understand I can perform all these things in the cloud, so this local box doesn't need that to be that beefy. However, then what's the bandwidth and the throughput that's guaranteed or that I can request, because this still is a service. You can give me 200 megs or 500 of the gig, but how much you handle for that? Because also it has to be then provisioned twice, right? It will be a backup connection, it will be an active one. Sorry for the whole thing.
Yeah, agree. So first thing, they don't share bandwidth. The tunnel does not share bandwidth. Tunnel has dedicated 500 Mbps bandwidth. And then that 500 is also carried over to the security. So I'll give you an example. If you have an MX box, for example, Meraki, let's say MX75, its capability is 1 gig for uplink today.
Okay.
But when you turn on the security services, that becomes 750 on the branch, okay? Now, Auto VPN tunnel actually gives 500 Mbps on that lower end desktop models. So if I have that Auto VPN fabric from a branch to my cloud, it's still 500 Mbps. So you're not losing anything ultimately is what I'm saying.
I guess it all depends on your use cases, yeah? If you have a voice over IP solution that goes still branch to branch office, then maybe the older option is a better one with full mesh. If you are totally cloud integrated and all your VoIP real-time traffic is going to the cloud in any case, then this is maybe the better topology for you, yeah? So
right, and then
yes, it will depend on exactly what you need, because if it's spoke to spoke and this type of dynamic traffic that would require then a lower latency, then you're definitely going to send it towards the internet and back anyway. But I guess you can play with both. It's just deciding also, do you want to put the processing on the branch? Do you have the money for that? Or you want to put the processing somewhere else because you want to put a very low end device in the branch and then save some bucks on this? It really depends.
So from a kind of high-level architecture question becomes a question of what's your corporate strategy around SaaS services at the branch anyway. I don't want to put a bunch of intelligence. If I'm dumbing up my network intelligence at the edge, why then would I then put a PBX at the edge? I'm moving to a SaaS and cloud-centric model. So if I still want to put heavy services at the edge, mesh network makes sense. But if I'm centralizing services, then I want a solution that kind of centralizes services within a cloud model.
right
Are there any hardware limitations
on the
on this solution, or
No.
it works across any?
right any Meraki SD-WAN devices except for whatever is end of sale, end of life. Just a disclaimer there. Yes.
There's I have a high critical application that require low latency, and I need to have a direct branch-to-branch communication. Is there a way to enforce locally some security feature you have in cloud?
So you can do two things. On the branch, you can bypass that traffic from the security and investigations. And that way, we don't run that on the branch for security stack. And then you set the QoS policies on top so that those packets always take priority over the others.
Okay,
So once you do that, then the fabric will honor the QoS and send the traffic over from one destination to another destination. So those are the two techniques you can implement to improvise. If you have a SaaS applications, which normally does not require a lot of security investigations, in that case, our recommendation is you bypass that from the fabric and do DIA. And then you can run some security checks on the branch itself, which are exactly like similar to what you can run in the cloud as well. But you can do DIA and improve the performance that way. So there are multiple choices you have from the branch perspective.
Okay, so it can be actually hybrid. You can have some things that you send somewhere else, and others you can just bypass them and send them over as SaaS. Okay,
Right,
good.
yeah. And then you can also do performance-based routing on top. So you set some profile saying that I can only bear this much latency. If this tunnel has latency in more than this, move over to the next one.
So I don't know if you're going to get to it or not, but so for SaaS services, not just SaaS services, but internal services running on cloud, can we do something akin to a direct connect from your cloud into cloud providers?
Yes. So
Sorry, hey, my bad. Just for the performance routing, is it only working if you want to prefer one tunnel over another, or if for any reason you realize that both tunnels don't have the required latency measurements, then can you just say, okay, then if it doesn't work in these and these tunnels, just send this locally? Can we broken down locally then?
Yeah, what happens is you first have to choose your preferred uplink, okay? And then you have an option called active-active or round-robin traffic forwarding. So you decide that. Once you do that, it will always try to send it to the uplink that is your preferred as long as it meets those standards that you define. The moment you not meet the standard, it moves to the second. In the case when you don't have both uplinks providing the standards, it will pick the best out of the two, because you didn't define that I need to do DIA for this.
Okay, so you either do DIA or you just send it through the tunnels, but it will not be just floating there in case the tunnels are not performing, and then can just break it locally, right?
Yeah, and in internet destinations or SaaS cases, when you're trying to send a traffic over the tunnel, but for any reason the tunnels are down, the last resort is always DIA.
Wonderful.
So it will always go to the DIA. The problem is if it's your internal destinations, the internet will gonna block it because they don't know what that is, right?
But still, the tunnel must be down, not underperforming.
Exactly.
That's a difference.
Yeah.
So if it's a brownout, then we can end up in this, oh God, where'd I go?
Right.
Wonderful. Thank you very much.
Yeah, no problem. To answer your question. So in the cloud providers, you can deploy a virtual instance that are available from Meraki, and then connect those virtual instances to our fabric, and you establish the connectivity.
So the challenge with that is, one, I'm going through is this like a marketplace thing, or is it a EC2 instance that I'm deploying it on manually? So I don't get the integrated features of having a direct connect or the lower rates, the lower egress rates coming out of the cloud back into my Meraki cloud. So I'm assuming, right, Meraki to Meraki, I'm not paying egress, but anytime I leave Meraki going into the cloud, I'm paying egress.
Yeah, so that's a marketplace EC2 marketplace VMX or virtual instance that you will have to basically order from the provider and then spin up an EC2 instance to run those on top. That's what it is for now. Maybe there's a session in the next segment where I think they're going to talk about the virtualization of VMXs in depth.
Thank you.
Hey everyone, can we let him get through the rest of the slides?
Sorry.
That's okay.
That's why I'm saying it now.
Yeah. All right. This is our global footprint. As you can see, we are globally available through multiple regions. In Asia Pacific, we have some data centers in Australia, US, Europe, India, and Hong Kong. So they're all, and then we are keeping adding more and more as we need, as we come to the market demand. So based on the demand, we will keep prioritizing adding more data centers. But for now, this is what it is. I have added a link here that actually explains in a detailed way what are the capabilities and all per data center. So I'll be happy to share that. Next thing I want to share is cloud security functions. So there's a sequence in place when it comes to inspecting the traffic through our cloud security stack. First and foremost, the DNS inspection will happen. So anytime you try to go to the destination, DNS will be inspected first. Once you pass that check, then it goes through our cloud firewall engine. Cloud firewall engine is developed in a way that it also provides an IPS inspection on top for internet-bound traffic. If it's a non-web traffic, the cloud firewall is your engine to kind of block or allow based on the app category and signatures. If it's in web traffic, we also can then forward it to the SWG engine, which then do further inspection from the CASP or DLP perspective. And then you can send the traffic out to the internet or SaaS-based destinations, depending on what the destination is. So this is a sequence of our policy enforcement queue engine. But today I'm going to talk about more on the firewall side. Specifically solving challenge of how to implement global policies at scale. So one of the challenges that we always run into, this is also true for a multi-vendor solution or even in a single vendor solution, that you have branches and you have cloud. Now, oftentimes you're wondering is like, where do I actually place a policy to actually enforce it in an effective way? So then what you end up doing is you just place it everywhere. That's one option. The other option is, depending on what the destination is, I just plug it into the destination enforcement engine, and I'll just expect that traffic will hit there. Based on it, I'll just go from there. Our approach is slightly different. What we are trying to do is we put the policy closest to the source, which means like when a traffic comes to the engine, based on the source, we will determine what needs to be allowed, what needs to be denied, and then that way we save the bandwidth over the tunnel as well. Like if unnecessary traffic don't need to come to the cloud, if they're supposed to be blocked on the branch. But to do so, one of the key problem is, like, if you have 50 networks, you have to replicate the same policies across 50 branches, right? So a simple example could be that, let's say I have an intent, like I want to block a social media destinations, and then I want to enforce it on all my branches and the cloud firewall, because my remote access users are coming from the cloud side, branch users, of course, coming from the branch perimeter device. So what you do is you will start configuring the policy, and then one at a time on each of these locations. What we are developing is a centralized management interfaces where you just define this intent and then define the enforcement points. And once you do that, we will just send the policies out to all your intended places. That way you just configure one rule, put it out everywhere. This is a control plane environment. Now moving to the data plane environment. So in this case, I'm taking an example. A user is in the branch working, and he's trying to go to a social media website, for example, like facebook.com, because the policies are in both places. When they send the traffic to the branch will evaluate the same policy and block it. Fast forward a few days later, if the user decides that, hey, I'm working from my home, so the user moves to remote locations, again do the same thing. It's like, I want to go to the facebook.com. Because the same policy is also enforced in the branch, traffic comes into the same policy is enforced in the cloud, traffic comes to the cloud, again gets blocked. So this is a single global policy approach where we do centralized management but distributed enforcement.
Just one quick one on this. I like it. Nobody wants to manage all these hundreds of devices. Just if you enforce something, how long will it take until it is active on all these branches? Common time.
Yeah, so in Meraki, typically when you configure something, instantaneously pushed to the devices. That's the same mechanism we're using here. So it doesn't have any delays attached.
So it should be near real time.
Near real time.
Excellent.
Yeah. All right. So I'm going to show you a demo of the same thing, how you configure a policy, how you enforce the policy on those various branches. So again, same Meraki dashboard. We're going to the SD-WAN and firewall page just to make sure that there's nothing there right now. But this global policy shows up as a link to redirect to the page. Now I'm here in the org-wide firewall policy page, trying to add a rule here. My intent is to block social media access. Or block anonymizer in this case. So I'm just gonna type the rule name. And then the sources can be anything, like remote access, user groups, or servers, or destinations, depending on your, like, let's say VLANs or IP address or subnet. And then I select that as a destination. See, I have the list here that I can apply. Now I know for a fact that my remote access users will never come from the branch. That's why I was only enforcing that in the cloud. You wouldn't even get the option to select for branch because it doesn't make sense. That's never going to happen. In the same case, I'm going to create another policy where I know for a fact that the users will come to the branch and also goes to the work from the remote location. So I'm saying, like, block branch to social media. And then I'm going to create a subnet, which is my branch superset here. And then I'm going to select social media as my category and then specify the enforcement. Now you can see I have all the options here. Select that and then apply and review the rule. Make sure everything looks good, confirm. As soon as I hit that button, see that waiting sign? As soon as the waiting sign is done, your rules are already pushed in place and they are enforcing the traffic as needed. So it is as near time as possible. And now you can also confirm to go to the localized page. It's like, okay, where are those rules? Can I actually verify them? Can I see them? Just to confirm that it's actually doing its job. So you can do that. You can come to the cloud firewall page. That's your anonymizer block rule. And that's your social media block rule right there that I actually configure from a global standpoint. So that's my demo of how org-wide firewall works. Any questions?
How do these signatures work, and are you able to detect whether you're hitting a social media site or Google when the client's using Quick?
No, Quick is something we are still working on. So Quick will be coming in the next few months, but in the meantime, we are using our SD-AVC engine, which is powered by NBAR. So that's the brain behind detecting the signatures and apps.
I assume this is also linked to Talos, though.
Who?
Talos.
Yes. Yes.
You will be then connecting to and updating all the
Yeah.
signatures there, right? Okay.
Yeah. So powering the Talos engine, integrating with NBAR, coming together as a superset of list.
Is integration already there for Catalyst SD-WAN as well?
This is primarily only for MX and Secure Connect right now,
Okay.
but Catalyst will come as a future roadmap item.
Got it.
Yes.
One of the things you said is this is being developed as essential management. So it's not available at the moment, but it's in progress?
This is available as a beta feature right now, but it's still limited to layer 7. We are also developing layer 3 on top. So now you can also maintain your ACLs that you're maintaining on the firewall through the global level. Now, some of the things that we are focusing on is like when somebody tries to configure these rules via like subnets or VLANs, or the primary thing is like, how many rules am I going to configure, right? And some of the rules will just keep repeating, whether if you don't know or you're changing your administrator and they don't know how to process this rule, they will just end up creating more and more rules. So to help you clean up those things, one of the initiative we took is like you create objects which reference to those entities, whether this is a engineering resource, for example, or whatever the case may be, right? The other thing we took is like we have dynamic object capability in our system. So let's say you have a streamlined VLANs applied to all of your branches and DCs. So you pick VLAN ID, we detect which branch has this VLAN ID, and then you don't have to create the rules per separate subnet. You create the rule by VLAN ID, and that ID will be a key for me to associate the rule to those impacted branches. That way, an admin don't need to go to the branch to look at like what subnet am I going to actually take care of. Or once they figure out all the subnets, they don't need to summarize that for their rule creation process. No, that's just like too much work. So we're going to eliminate those headaches, and then we will give you a simplest method to actually apply those rules.
For, assuming it's not a well-organized network, which is probably their reality, then it also works and well, it is backwards compatible with my network is a mess type of approach, right? Okay, good.
Always, yeah.
Because the attacks are cute as long as it's well designed, but that's in most cases a fantasy.
The idea is like this might motivate them to go to the organized networks.
And then,
So if I want to implement the policy, and it's already there, it will give you an alert or sign that's already there, because maybe some policies are nested or.
So one thing is if it's exact match, we can alert you saying that this is a duplicate of something. Do you still want to proceed? But that's being developed. It's not there. But that's something that we can come up with,
It's possible to apply different, It's possible to apply different rule based on the tunnel that of the branch device that is connected to the network without thinking about VLANs, overlapping APs, identities.
Not today, but good question. This is also a roadmap item. We are developing an object called site, and that will help you achieve the exact same thing. Yeah.
Very useful in the real world, mostly retail
when it's mess,
environment.
Yes.
I think I've got my question now. Sorry.
So this is a Meraki word. In your example, a user got disconnected, go home, work from home, Then the SSE enforcement comes in. Do I have now to set up the same policy again in SSE, or do you sync somehow between these policies and the policies that are in SSE?
No, the Secure Connect is your SSE, right? So what I showed earlier, this cloud firewall is actually an SSE platform. So I already configured the policy for SSE as well at the same time.
So I have a single control plane. I just need to define it one time, and then this is defined on both words, more or less.
Exactly, yeah.
When do you think this will be ready for ZTNA and being able to apply policy based on user ID or user group?
Partially, it's already there. So remote access is already with the user IDs and stuff. For branch, it's still work in progress. Yeah.
For the inspection, security inspection, on devices unmanaged in the branch, do we still need to enforce certificates to inspect the SSL connections?
Only when you are using the engine in the cloud for SSL decryption or DLP, right? But other than that, you don't need certificate now.
For the DNS, IPsec, of course.
Yeah, you don't need certificate now.
And another question was related to the IPsec part. Okay, IPsec is full IP, I think, while as WGIC, as BDLP are only on inspecting 80 and 4-foot report. Is there a way to detect if there are any HTTP protocols working on non-standard ports and then try to redirect or to the SVG as well?
Yeah, so when you define the rule, you just have to define those ports with the TCP, HTTP, HTTPS protocol selector. That way we know for a fact that when I see this protocol, it's HTTP, HTTPS traffic, or the port number specifically, the destination. That way, then I can route that through SWG. Okay. If I'm not mistaken, actually Cloud Firewall can detect the header as well, so which is HTTP, HTTPS header. So regardless of what port source you use, we just know from the header that this is an HTTP, and we can redirect to SWG. Yes.
Thank you. For auditing the rules, because obviously you need to do that every year, or hopefully do it every year. Is there an easy way for for me, for example, to audit all the team, everybody's rules that they put in place and see which ones are not following our standard, for example? What would be the most simple way to do that?
So right now, I don't have the most simple way, I would say. There are multiple pieces here to get together to make it simplified. But one of the things that we are going to focus on is how can I actually help you eliminate unnecessary rules by two techniques mainly. One is like if this rule is being used over how long of a period. And here's where the debate is, like, how long should I actually allow you to? Because sometimes one customer I talked to, they're like, oh, but I have one server that always get accessed every year. Does that mean, like, do I have to wait for a year to not see the use of the rule and then I can delete? See, those are the challenges that we are dealing with right now. But once I sort that out, I think the key here is we have ways to kind of improve this whole experience. But these are the nuances that we are actually going through right now to figure out how can I help you here.
So a couple of questions from me. First one is all of this possible via API?
Some yes. Whatever is in beta feature is not. We are developing the APIs for that. But idea is API first.
Eventually it will be, you're right, yeah. And then secondly, what's the licensing for this? Is it included in what you've already purchased? Is there some sort of license to combine those things needed, or?
No. So again, Meraki's simple license philosophy is like you buy one license, which includes the feature depending on the tier, of course. Mm-hmm. So if enterprise license is there, it has layer 3 firewall, advanced security or SD-WAN plus gets layer 7 firewall. And then you buy Secure Connect on top as a subscription. Yeah. And you get all this other functionality too. So it's not like you already have something, you want this, you buy something. That's not
link it together. And yeah, okay, great.
So are there any egress charges associated with branch-to-branch communication, cloud-to-cloud communication, or more importantly, when I leave the network to go to a public cloud or publicly accessible?
Yeah, so one way to meter is when you have, let's say, one seat has 20 gig traffic limit, right, per month. That's a subscription contract that you're going to do with us, right? And the metering is not based on egress or ingress point. It's how much traffic a branch has sent or received over a period of time. If that exceeds 20 gig, that's when you will be flagged. It's like, okay, you're going above your expected limit. At that point, you as a customer has a flexibility to add more seats, increase the pool.
So do I have reporting on like file shares. I know we don't do this as often as all, but file share is probably the easiest example of reporting that says, hey, you know what, you might be either served better by putting some type of cache locally at a branch because you're getting this common request or application communication, and then instead of buying more seats, you can put a service locally.
Right, yes. So those type of analysis are available through our traffic analytics engine. So within the Meraki dashboard, you can see which application or traffic type is actually hogging this limit. And then if you can do something about it, it's totally in your control, whatever the action you want to take. Yes.
And does that give you a per user breakdown as well? So you can see, right, it's that one person that's using,
Not per user right now. Yeah.